Evan, for folks that don't know, what are you up to at Nebius?
Yes, thanks for having me here. Nebius is one of the world's leading AI clouds. We provide some of the best price performance, but it's not just compute, which is what everyone thinks we do. We actually provide a full stack platform. So everything from the infrastructure to the managed services for virtualization, containerization, Kubernetes, all the different MLOps tools and AIOps tools used to build pipelines and train models. And yeah, I like to say we are what an AWS would be if they started today. So we're not a neo cloud, as some people like to say. We are a true hyperscaler, but an AI hyperscaler.
Now, when we met up yesterday and we were chatting, I had said it to you. I had you in as a kind of a startup,
Yeah,
but then I understood you have all the stack, and I was like, how did you get that done so quick? There's a history there.
yeah, for sure. Yeah, we're the best of both worlds. We operate and move and run like a startup, which is awesome. Incredible urgency and pace. But we're a big mature company. We're almost 2,000 people. We're public. Went public a few years ago, but we didn't just come out of nowhere like some of these other neo clouds. We've been building clouds for almost 20 years. Rich history building cloud software, and now we're bringing it to the rest of the world.
You were describing it that you're an AI native hyperscaler,
Yeah.
the ultimate AI cloud. What do you mean by that?
I think it's the fact that at each layer of the stack, we are providing really the best in breed. So with the compute layer, we have all the best NVIDIA chips, InfiniBand for the top performance. But even like storage, most neoclouds don't have like a full storage platform. We have like HPC grade storage with throughput and latency that is really 2x the performance you see from your non-standard, non-hyperscaler level storage. But then I think what also makes us unique is that we have vertical offerings. So like what I'm doing. So I'm building a physical AI platform purpose-built for physical AI specific workloads, right? So not just generic compute, generic ML training pipelines, but pipelines and workflows for physical AI, which we of course can get into.
And you mentioned yesterday in your presentations around everybody talks about the data flywheel, and you made the comment, which I think is very valid, in that it's not exactly flying around these
Yeah.
days. There's some features in that,
Exactly.
and you were talking about the fact that you want to make iteration faster.
Yeah.
Can you expand on that?
Yeah, sure. Iteration speed, the speed of that flywheel is really an emergent property of a few things. The first is at the compute layer, right? People think they're buying GPU hours, but they should be thinking about buying completed training runs and the speed at which that training run can get done. That's a factor of your raw compute horsepower.
Right.
And there's a few benchmarks out there that NVIDIA has. Our benchmarks are actually better than what even NVIDIA can achieve when it comes to the overall speed of communication and transactions per second on their chips. All right, so we're at 104% to the NVIDIA benchmark. What does that mean to the general user? You combine that with our mean time to recovery, mean time between failure. We complete training runs. If it takes a general purpose cloud around like 100 hours, this is all dependent upon the size of the cluster, but roughly speaking, it'll take us around 70 to 80 hours to do a similar
20,
training
30%.
run. So that compounds over every single run over weeks, months, years. So you get to a completed training run faster, which means a model can come out and go into your evaluation process and the simulation, other parts of that flywheel faster. That's one thing. The other is the DevOps process.
Yeah.
In physical AI, you have lots of different compute environments for your training runs, for simulation and eval, and then even pushing it out to the edge where you're doing inference. Each of those requires their own pipelines, their own software code to speak to the right GPUs in those environments. And there's all kinds of like glue code you got to build to make them all work in harmony. And developers spend a third of their time building pipelines, and they should be putting that time to building robot brains. So we're doing a lot of things to help abstract away all the, I guess, differences between those compute environments and treat them as one system via one pane of glass. And to do that, we're actually partnering with NVIDIA. So NVIDIA has their Osmo orchestration framework, which is built for physical AI, built for heterogeneous compute environments. It allows you to build one pipeline instead of 3 or 4. And it's simple as that, right? So you're just going from, days to stand up these pipelines to hours. So I'd say those are the two biggest areas where we're really helping create faster iteration speed.
You also spoke about yesterday your, and you mentioned it, your physical AI platform. What's that?
Yeah. Part of it is the orchestration tool mentioned, Osmo.
Mm-hmm.
It's a big component of it. That's just about faster orchestration between your training, simulation, and your inference environments. But on top of that, we're building a few different solutions, some first party, some with partners. The first one is with NVIDIA.
Okay.
So one of the biggest challenges is getting enough data, enough variety of data to train your models.
Yep.
And a lot of companies have tons of data from teleoperations, from camera feeds of different types, or they're getting data from simulation, but they don't always have that long tail in that data when it comes to like certain lighting conditions, certain objects, like putting all of a sudden a pair of glasses in the scene, weather conditions.
So multiple
Yeah.
scenarios and variations.
Exactly. And so it's too much effort and time to go and recreate a video scene or a simulation scene with those. So what we're doing is we're building out a synthetic data generation pipeline.
Okay.
We're using NVIDIA's Cosmos world models, which allows you to take in video data, augment it with new content, information, backgrounds, lighting, you name it. And then they have the Cosmos reason model as well, which allows you to QA check all that video data to make sure, is it high fidelity enough? Is it exactly what you're looking for? And then out the other end, you get a whole new data set that didn't exist before to now train your model and cover those edge cases. So that's one example of a solution on top of the orchestration framework. And then for things like simulation, we are forming partnerships with some of the best companies in the space that make it way more turnkey to bring in your full autonomy stack from your robot and do auto scaling when you're taking like things like Isaac Sim and Isaac Lab to scale out your simulations. And today customers have to go and build out and containerize their own perception stack and autonomy stacks. They have to go build out virtual scenes. These partners have that stuff off the shelf. So that's one area. The third area is at the data layer. It's very, like one of the biggest bottlenecks is not just capturing the data, but then figuring out where in your data you have certain episodes, certain failure events, and then easily curating that data and easily labeling that data. So we're partnering there with Voxel 51. So Voxel 51, they're like a data lake house for robotics and visual data. And they make it super, super easy to go in there and upload your data, quickly find scenes, label it in one environment, eval it on your model, see how it performed against that data, and then go push that data set into a larger training run to go actually train it at scale. So between data, orchestration for training, simulation, data pipelines, we're covering most of the flywheel there. So really the idea is come to one place to spin your entire flywheel.
Your customer for this, the guys making the robots, the guys deploying the robots, the guys building factories, all of the above, or?
Mainly companies building the robot brains and the robots today. A lot of the stuff we're building across this flywheel will definitely translate over to the enterprise space.
Right.
They'll need similar tools when they go deploy and post-train and manage their own robots, like managing the data, doing simulation. But today it's mostly AI native, physical AI native startups who are trying to build robot brains to have efficacy in the world before it can even get adopted by the enterprises, right?
Okay. Hannover Messe, any takeaways from yourself from being here?
Man, lots of humanoids running around.
There are?
So almost every booth is doing big time automation. There's a humanoid being showcased. So that's cool to see. I think people are in the experimentation phase there, but at least people are learning. So we'll get a lot of, I think next year, a lot of people will be able to say, hey, it worked or it didn't. Almost every company that is building some kind of automation software, it's like OT-based software, they're finding ways to pipe that data into simulation environments like NVIDIA Omniverse to create digital twins. So you're seeing a lot more digital twins out there in the world now, which is great. That was just kind of a buzzword and a concept now, but now you're seeing it come to life in lots of different companies, lots of different contexts. You're seeing all the SIs, like the Accentures, the EYs, they're all taking this stuff really, really, really seriously, and they're realizing how hard it is to bring OT data with IT data, with robots, and they're figuring out like, wow, you got to figure out how to create like a unified data layer, a common data model, a master data model that AI agents and robots can reason about to actually have shared context in the world alongside humans. So I think the fact that you're seeing SIs take the space so seriously is critical, because we're gonna need their expertise to come in there and do a lot of the heavy lifting of integration of disparate systems.
No, I agreed. And I also see, and obviously industrial AI and, but I find it fascinating that even last year you were saying that you had a few humanoids, way more this year. But even with, let's say, automation, industrial AI, people were kind of doing it in one department within a company. So still in one silo.
Yeah.
A lot more discussions this year about, hang on a second now, this stuff works, but we can't just do it in our silo. We need to do it kind of across the food chain in the company. So it's forcing those silos to be, we need to, these need to go away.
Yeah.
So but again, it kind of comes back to the art of the possible. Yeah, absolutely. But now we need the tooling, the platforms to make it happen.
Yeah,
Because it's not trivial, right? We need to make it easier for people, but this stuff isn't that easy to do on your own, right?
No. It's going to take years for this to all get figured out, but at least it's starting to happen now.
Yeah. Hey, good stuff. Thank you very much.
Actually, pleasure. Of course.